Good morning, ladies and gentlemen. I hope you all are having a good day. Today we're going to continue talking about food chains, and we're going to compare those to what we call food webs. And let me straighten out my camera here. As a reminder, today is the last day I'll take any other late work up to midnight, and after that I'm done. So please finish that up and get it into me before then. Sorry. Let's go ahead and get started. So as a reminder, this is the topic we're working on. Know that interactions occur between matter and energy. And one thing I want you to remember, this is just how incredible science is that everything that's on the planet, everything that you can see and feel and stuff, happens because of energy that comes to us from the sun. So radiant energy, brings all the energy that exists on our planet. Now, some of it is geothermal, right? Some of it is from the planet, the hot core and stuff, but I'd say 98% of it is comes from the sun. So all the living things on our planet depend on that. And radiant energy becomes these solids, glucose, that's sugar, that becomes matter. And we all live on that. So we are going to practice just using those arrows, diagramming how they, to show how energy flows through these living systems. And there's a shortened version of what you should be putting in your notes, and I'll put in mine, showing just what food chains are compared to food webs. And then we're going to put all of that into what we call energy pyramids. So what are food webs? So yesterday we talked about food chains, and we saw that it just means how energy is passed from one organism straight to another, then straight to another. But, nature is more complex than that. And really, we need food webs to get a better idea when we're looking at an ecosystem, how it really operates. So food web, it says a food web consists of all the food chains in a single ecosystem. So we just took one single ecosystem, just using a food chain wouldn't work. It wouldn't be reality, because there are so many different organisms that depend on one another, eat one another, and so forth. We really need webs to give us a better picture of what they look like. So it says each living thing in an ecosystem is part of multiple food chains. Each food chain is one possible path that energy and nutrients may take as they move through the ecosystem. So a grasshopper may belong to 4 different food chains. And it just depends what happens in its life, what chain it follows. And that's what we're going to be looking at from this point on. We're going to deal more in food webs. But you have to know how a food chain works, because within the food webs, there's going to be many food chains. So here's a graphic that's a great example. It shows you a food chain, and it's only one path. It only goes from here, the producer, to the primary consumer, secondary consumer, and tertiary consumer. And the reality is that this producer is the source of energy for many different organisms, not just the grasshopper here. That's not reality. And we can see every time you see an arrow, remember, it means energy is going from one organism to another. The energy from the plant is going into the grasshopper. The energy from the grasshopper could go to the bird, or it could go to this mousy-looking creature. But this is more a reality. And even then, I think if we took a block in any a city, the number of organisms within a certain area is ridiculously tremendous. But This is more real life than this is. But this is a good start, right? It gave us the understanding that we start with the producer that makes the glucose, then feeds the primary, secondary, and tertiary. Okay? Now we're applying it to the reality that we see in the world. So to review these two terms, producers and consumers, when you think producers, just think that P in producers is the P for plants. Okay? Plants are the producers. And why are they called producers? Because they produce glucose. That is a food that every other organism on this planet lives on. Okay? So remember, the plant makes the food for itself. Here we have consumers. So consumers are all the animals on our planet. And I know there's plants behind there, and later I thought I should have picked a different picture. Ignore the plants and just look at the animals. So producers make their own foods. This is plants only. Consumers, they use or eat other organisms for food, and that can include plants or animals. So a cow is a consumer because it eats plants. That's an organism. So again, producers make their own food, and as you look at this graphic on the screen, and let me push it up a little so we can zoom in and see that a little bigger. So of what you see in either the food chain or the food web, what would be the things we would consider producers? I hope you picked all of these, okay? These are the plants that exist in this graphic we're looking at, okay? If it's a plant, it's a producer. Consumers, again, they use or eat other organisms as their food. So as you look at this graphic, what would be the things considered consumers? Anything that's an animal, okay? And remember, whether they eat only plants or they eat only meat or they eat both, they're considered consumers. They have to consume other organisms to survive. They cannot make their own food. Only plants can do that. All right, let's watch this video.
Let's visit an underwater forest near Monterey, California, where kelp grows over 100 feet tall, reaching towards the sunlight above. Its fallen blades litter the seafloor below, providing nutrients for a host of creatures, including these spiny purple sea urchins, which move slowly in search of food. Sea urchins make a tasty meal for this marine mammal. Sea otters help keep the sea urchin population in check. Too many sea urchins will devour living kelp, destroying the forest. We consider otters a keystone species. As active predators, they protect kelp from hungry herbivores like sea urchins, and help maintain diversity and balance in this ecosystem. But we're seeing just one small part of an intricate network. Sunflower stars also prey on sea urchins, and may become dinner for a hungry sea otter. But otters prefer abalone and crabs. From the smallest microbes to the largest animals, these species take part in a diverse food web that links more than 1,000 species. The connections in the web represent the transfer of energy with every meal. At the California Academy of Sciences, paleontologist Peter Rupnerine studies both modern-day food webs, like this one, and those from the past.
Basically, a food web is a map of all of the interactions, what we call the trophic interactions, in an ecosystem or community. And those are predator-prey interactions. Who eats whom, who eats you, what do you eat, and so on. The food web is one of, if not the most important representation of interactions that we have in an ecosystem, because it's a main passage of energy through that system. Energy is produced, it's consumed, and everything else runs on that.
Let's take a closer look at our marine ecosystem off the coast of California. What connections do you see in this food web? Can you predict the flow of energy between otters, urchins, and kelp? From primary producers to top predators, this dynamic ecosystem supports a diverse set of species. Small changes, however, can have big impacts across the entire community. Imagine you're a citizen scientist exploring marine ecosystems on the California coast. You visit the same kelp forest every year and observe sea otters, sea urchins, and kelp populations. Looking over your field notes now, what trends do you see? How are otters, urchins, and kelp connected? Take a moment to pause the video and examine your graph. Here we see the impact sea otters have as a keystone species. When otters are present, urchin and kelp populations are stable. When absent, though, urchins boom and kelp beds are reduced. Let's take another look at our coastal food web. Can you predict how a removal of sea otters would impact the flow of energy through the system? Which species would be negatively impacted? Would any be positively impacted? Pause the video to take a closer look.
Okay, so to look at the impact of an organism like the sea otter, he's at the top of the food chain here, you have to see everything, what's impacted by him. And all you have to do is follow the arrows. All these things that you see give their energy to the otter is because he eats those things. So without the otter, the number of sea urchins would go up, the number of sea stars, crabs, and these larger fish would go up. So if the number of sea urchins go up, you have to, if I follow this back, it's going to tell me what the sea urchin eats. If there's more sea urchins, they're going to eat more of whatever that energy is. So that's how we can see what impact an animal like a sea otter would have. Without them, you'd have a lot more fish. You'd have more crabs. And is that a good thing? So this is nature finely tuned. When sometimes man tries to interfere by saying, oh, you know, there's too many sea urchins and they're eating all the kelp. Let's go in and let's bring in a lot of sea stars to take care of them. Well, that's just going to throw nature off. Nature usually figures out a way to take care of itself.
Removal of a keystone species, like the sea otter, has cascading effects, impacting populations across multiple trophic levels and disrupting the flow of energy through the entire system. Understanding ecosystems and the various threads that connect species together in food webs can help us better direct resources for conservation efforts, and, most importantly, come to sustain these diverse networks of life.
Alrighty, so again, you know, it's usually when man interferes with nature that things do not go well. So we're better off leaving nature alone to take care of itself. So here's an example of a coastal food web like the one we just saw that you're going to draw, or we're going to draw into our notebooks. So remember, it always starts with the producers. In this case, the kelp, that long seagrass you saw growing, and phytoplankton. So phytoplankton are tiny, tiny little plants that live in the ocean. They produce a huge amount of the oxygen in our atmospheres, probably more than the forest on the land. Phytoplankton produce, take in carbon, as in the pollution, and produce oxygen for us. So we really need to take better care of our oceans, because more of our oxygen is actually produced in the ocean. But these are the producers. They are producing the glucose needed to feed the animals. So the first one here is the sea urchin, and he loves to eat kelp. And you can see that's what this arrow is showing. The energy from the kelp goes into the sea urchin. Why? Because the sea urchin eats it. Again, following the arrow, remember the arrows mean the flow of energy. Sea otters love to eat sea urchins. So the energy that the sea otter needs to live his best life, you know, to mate and have pups, to swim, to grow new fur, is because he's getting energy from the sea urchin that it got from the glucose from the kelp to live his best life. But remember, this is a food web. So this food chain is accurate, but it's not the total picture. We also know that sea stars or starfish love to eat sea urchin. So sea urchin's energy goes towards sea otters and sea stars. Sea urchins also eat phytoplankton. Mussels eat phytoplankton as well. Crabs like to eat mussels and they eat sea stars. And energy from crabs goes to sustain fish as well as otters. Remember, as you are following the arrows, they mean the movement of energy from one organism to another. And then at the top of this particular food chain are sharks. Okay, they're the top predator here. There we go. So we can see that there can be many, many layers in one food chain, but many food chains can interact and create a food web. And here we have, starting with algae. This is our producer. And again, notice it's rare that you will see an arrow going towards the producer. And that's because the only thing that a producer may take in as energy is when any of these animals die, their nutrients will help feed the algae. But there's no arrow going towards it. All the arrows move away from it. That pretty much tells you, even if you didn't know what ice algae was, that should tell you, hey, there's no arrow coming towards it. That means it's the producer. But we can see that that algae provides food for these little zooplankton. When you see some kids get confused between phytoplankton and zooplankton, just look at what the first three letters are. Z-O-O, zoo. That means animal. So this is an animal, okay? So we have ice algae, and we also have phytoplankton. Notice there's no arrows going towards it. All the arrows move away because this is another producer. Yet, I want you to just take notice how there's many food chains overlaying each other, making a food web. Okay, so the advantages of using food webs to learn how energy moves is that it gives us just a better picture of what an ecosystem really looks like. It also shows us how these organisms interact and how they're dependent on one another for energy. And it also shows you the importance of each organism. And the reality is that every organism in here is important. If you remove any one thing, you're gonna affect other organisms. That's why, people think, well, let's get rid of all of this type of insect, or let's get rid of this kind of animal. And I've only heard scientists say about two things that the world would be fine without. One of them is mosquitoes, because they cause so much disease to humans and animals. And the second, here in South Texas, we have lots of wild boar, the javelinas. You can hunt javelinas any time of the year, and as many as you want, because they're considered pests. We don't have any big predators that, there are some pumas or like that may feed on them, but they're really a pest here in South Texas. But other than that, any one thing you take away is going to affect something else. If there's an arrow coming towards it or away from it, especially, then you're going to upset. Removing any one of these pieces is going to upset the entire food web of the system, of this ecosystem. If you have any questions and I haven't answered them, please feel free to ask me now or email me. Alrighty, so for today, you need to make sure you get those notes in, and I make sure I drop them into the electronic notebook. You have a daily discussion, which is like your exit, and then you have an assignment to do, very much like yesterday, very short as well. There shouldn't be a reason that you're falling behind on your work, because it's literally one question and a couple of questions. Alrighty, I hope y'all have a good day, and we'll talk again tomorrow.